fifth period, but I left it on to the trade classes. So I kind of had to leave that one. All right, so this is, we did that one, right? Find all the complex roots. It should be here. Now, you're doing the old guess and check technique where you come up with things to throw at this kind of synthetic division. How do you form that list of possible zeros? There you go. It's factors at the back. What is that back number? It's just 10. Ignore the sign. Just 10. Ignore the sign. Sitting over factors of the front, which is 1. Said understood one, by the way. Factors the back over the factors in front. What's it take to make it 10? Preferably in increasing order.
1, 2, plus 5, plus 7.
Well, I also was now, and then you guys ground. No, you wouldn't. It was not, and you're like, I'm taking over. All right, factors the front, the 1. All right, now, 3 of you weren't here yesterday, and we spent a whole lot of time taking a guess, plugging in synthetic division. What takes 20 minutes? You have that kind of time on test day? No, you don't. Yesterday, we took a 4th degree polynomial, this thing, and we reduced it down to 3x squared. I think it's plus 3x plus 3. Right? We took a 4th, we reduced it to x squared. Why did we reduce to x squared? At this point in time, x squared should make you very happy when you see them, because you can factor them, you can get the quadratic formula, you can shift to one number to the other side, maybe do square roots. You drop down to x squared because you know what to do with it. That's why you do it. So on the example that I have, how much do I need to pull from that thing? How many zeros need to get pulled from it? 1. Why 1 0? Because that's cubed. If I pull a 0 out, I'm going to be down to x squared, where I know how to do things, okay? By the way, you missed that too. Fundamental theorem of algebra, 3 zeros. I want to get down to where there's 2 left, because then I can do the quadratic formula. So everybody has a TI-84 in front of them. Specifically, a TI-84 is a graphing calculator. What do graphs tell you? Graphs tell you zeros. Go to y equals. Type in the equation. That's what you do on test day, kids. The graph will tell you nice zeros. It won't tell you ugly zeros like root 2. And it sure won't tell you imaginary ones, but it'll tell you nice zeros. You may or may not have it in y equals. Most of you probably do. Jason, no, it's not. I think you should. I hope it's you should have it. Zoom out. See, that's why I say it over and over and over. You said zoom 5. Zoom 6. Believe me, I don't like the idea of the constant repetition either. It works. It's got to be repeated. What is the 0 according to that? 2. Did I see that it's 2? That's a known 0. Was that in that list? Of course it was. That list has all the possible ones. So what that list is. If you want to be really old school. So what can we do with that 2? Put it on the outside, because on the outside is the value of x. And x was 2, 0. Second floor of the vinculum, what are the numbers? There you go. want you guys to go through the process real quick. Warm yourself up. Drop, multiply, add. Again, I know you guys don't know the formula for this, but I'm telling you, I'm not memorizing, you're just making things harder. That's all you are doing. You're trying to be lazy to some degree, and it's just not going to work for you. I never said this would be an easy course. Nothing I teach is easy. So drop, you add 1, you multiply, you add 2, you add, you add 0, you multiply, you add 0, you add, you add 5, you multiply, you add 10, 0. Why is it expected? Because it's the remainder, and it was a 0, wasn't it? All right. What does this represent as an expression of x? X squared plus no x plus 5. Because remember, if you've been absent, remainder constant x squared. You look at x squared plus 5. How many zeros are still there? 2. X squared. There's 2 zeros there. I want them. The example we did in class yesterday, we had to do the quadratic formula. Does this one require the quadratic formula? No, it's 2 steps. It's first step. Subtract 5. Next step. Square root. Real or imaginary? Imaginary root of 5. What symbols needs to be here for both answers? Plus or minus. I kind of want to spend, what time we got? 2:15? I might do it at the end of class. We'll see. There's an example I want to do with y'all. It's not in your notes. But we'll see what kind of time we have and everything said and done. Notice that, there's something going on here. You have a positive imaginary root of 5 and an imaginary root of 5. All right, here comes 2 theorems. One of them is called the irrational roots theorem. Anybody in here tell me what an irrational number is? It's not rational, which means it cannot be expressed as a fraction. That's what that means. It says it's not rational, cannot express it as a fraction. Middle school standard here, please. You have Buckley, you probably had to do Venn diagrams over and over and over and over and over to get your number stuff. Did it work? What is an irrational number? Yeah, there's more to it. Again, tell me what that means. It means decimal never stops. It's part of it. What else? Never what? Repeats. He said can't be expressed as a fraction. Is that a fraction? Yeah, that's a fraction. It's 1/3. That's rational. That's a ratio. Anybody know any examples of irrational numbers? Nobody knows an example of an irrational number. All right, the most famous of all of them. The second famous is actually this one, E, which we'll talk about after Christmas. You see it on the Facebook I got there? You see an E on there? Other than the alphanumeric E? There's an E of the X somewhere. That's the second most famous one. Know any other ones? Do you know the square root of 2? Do you know why nobody knows the square root of 2? Because it's irrational. The decimal never stops. There is no repetition in it whatsoever. You know the square root of 3. You know why you don't know the square root of 3? Because it's irrational. You could probably take a couple decimal places out and memorize it, but you wouldn't know it. Anyways, that's what irrational numbers are. The rational roots theorem says if a plus the root of b is a 0, its conjugate, it's just spelled better right there, a minus root b is also a 0. All right, down beneath that complex. What's a complex number? It's imaginary. It's actually a plus bi. You have a real plus an imaginary part. Got two parts, real plus. Sometimes the real part is 0. You might have 0 plus a negative 4i. You just wouldn't write the 0. Anyways, if a plus bi is a 0, that means something. What do you think it means based on the previous theorem? It's conjugate. You know the word conjugate. Conjugate, which is a minus bi, is also a 0. I wish we had some better examples in our notes we could look back on. But we don't, because I didn't make these notes. This is Vision Algebra 2 notes. Notice this previous answer we did? This one's technically a complex number. It's complex and irrational at the same time. But not only was positive I root of 5 a 0, what else was also a 0? The negative, okay? And pay attention to what's changing signs here. It's the weird stuff that changes signs. You know what? You know why I'm saying it's weird? One of them's not real and the other one's irrational. It's the weird things that change the sign. Did the first thing, the real piece, the thing that makes sense to you, ever change? No. That piece never changes. It's always the stuff that's kind of weird that changes. All right, what is a quadratic function p with rational coefficients in standard form such that p of x equals 0 has 2 plus 5i as a root? There's a lot of garbage in here. I'm not sure why they're writing things out here, but the big thing is, what is a quadratic function that has 2 plus 5i as a root? X to what power function you have on quadratic? X squared. I see quadratic, it's x squared all day long. If I'm x squared, how many factors do I have? 2, whether they're real or imaginary. I have 2 factors. If you're writing factors, each factor starts with what letter? X. Just the way it is, kids. Now, you're told that 2 plus 5i is a root, which means that its conjugate. What is its conjugate? There you go. 2 minus 5i is also a root. What happens to things when they enter parentheses? You say that, but quit screwing it up. Okay? You keep saying it. Don't mess it up. We're going to throw 2 plus 5i instead of parentheses. What is it going to become, Pace? No. That's right, Alyssa. Signs change. Doesn't matter how many things there are. Signs change. All right, next we're gonna throw 2 minus 5i, the second one that we came up with, into parentheses, and create what's gonna happen to it when there's parentheses. So what's it gonna be? There we go, -2 plus something. If that number was made of 3 elements, how the 3 things would change signs. That's just how it is. Signs do what? Change. Ah, but wait, there's more. Standard form. Yeah, that's worthy of the on. I agree. How are you gonna put that thing in standard form? What's that? It ain't FOIL. FOIL is 2 and 2, 2 times 2. So 2 things in each. It's not FOIL. You FOIL when you have 2 things. That's FOIL. First out and then last. This ain't FOIL. What property is it? Starts with a D. The distributive property, because you're gonna do it how many times? If you're saying, you told me what I'm supposed to do, I can't hear you, you gotta talk somewhat loud. Told you, half that. Wasn't kidding. I'm not even sure I hear anything, I was up here in there. All right, what do you get if you X all 3 pieces in the second set? X squared minus 2x. Okay. You're doing good. Plus 5ix, you don't like 5ix, what else would you like? You like 5xi. What do you want to do? Huh? 5xi? It's kind of the default. Because I is a number. I know. Sometimes you go to 5xi. Doesn't matter though. You do whatever you want. All right, what's next to distribute? -2. So distribute that -2 for us. -2x. Talk with some confidence. Keep going. +4. Minus 10 what? Yes. All right, what's last? All right, that gets the truth. Keep going. Anybody? I'm all right, -5 out of X, why not? Keep going. Minus, not negative. It's a negative times a negative, that's positive. Keep going. I squared. I times I is squared. Okay, information knows what I squared is. Listed is not. 3 knows. Daddy knows. Daddy is not. Beanie does not. What's that squared? -1. This piece is kind of special because I squared is -1. So if I take a -25 and multiply it by -1, what do I get? Positive 25. You have to memorize stuff, kids. I have to, otherwise you can't see all these connections. Now that looks really, really ugly. But there's a lot of things in there that can cancel each other out. Give me something that's going to cancel each other out. The xi's. Even though one of them's ix and one of them's xi, it's positive 5 and -5. They're the same thing. There you go. So this really ugly looking factoring, you have an x squared, take away how much x? 4, 2 -2's, and you got 4 and 25. 9. As ugly as the factors look, that's what she wants. Believe it or not, every single thing factors. Everything factors. The issue is sometimes it factors like that. That's the issue. We don't really teach you how to factor like that because you got to come up with the answers somehow. All right, let's do this one together so I can make something up and we can do something we need to do. Polynomial function q of degree 4 with rational coefficients has zeros at 3 minus root 7 and 4i. What is the polynomial equation in factored form? Because I'm not going to bore you with writing this out. Just factored form with these roots. All right, Parker, 3 minus root 7 is 0. What's its conjugate? Miley, 3 minus root 7 is 0. What's its conjugate? You doing math? Natalie, 3 minus root 7 is 0. What's its conjugate? Pretty close. What did I tell you about the weird things? What do they do? They change sign. You're doing conjugates, the weird things change sign. That's how it works. 4i is a 0. Allison, what's its conjugate? Negative 4i. 4i is weird. Change its sign, we have its conjugate. All right, we're supposed to write this out in factored form. It's a 4th degree polynomial, which means a 4th degree polynomial has how many factors? 4. 4 sets of parentheses, kids. 3, 4, 4 factors. They all are started with what letter? X. You can pick a different letter if you want. It's up to you. X is just the default. All right, so this happened to be a 0. Parker, what's it look like in a set of parentheses? No, it ain't plus. It's not plus 3. What happens to signs? Change. Negative 3. Keep going, my Parker. Yeah. Look at this one. Plus root sign. What happens to signs? Change. I don't like it. Just so many. Feeny. I'm looking at this one. What's it look like in a set of parentheses? Negative 3. Big one. I hate it for you, Parker, but somebody has to miss it for others. You're right. Miley. I'm looking at this one. What's it look like in parentheses? Miley. What else? And let's see here. Alyssa, looking at negative 4i. What's it look like in parentheses? Plus 4i. They all say thank you to Parker for missing, so you didn't have to. That's how it works. Somebody's got to miss it. All right, we're going to do one more. And by and large, I'm going to try and let you do most of it. If I can find it. I bet I've deleted it already. Ah, phooey. Ah, there it is. Cool. Found it. Completely factor this polynomial. Not that bad. It's really not. Now, I'm going to give you one little piece of information here. It's actually a great deal. Why did I put a 0 for them? There's no constant. That placeholder is actually pretty important. Now, you can sit here and you can play with factors of 128 over factors of 1. There's a lot of factors in 128. You can guess, and you can guess, and you can guess. Well, what can you do with it? Graph it. How many zeros do I need to pull from this thing so I can either factor it, square root, or quadratic form? 3. And that's the 5th, I need to pull 3 zeros out of it. Do synthetic division, 3 zeros, keep pulling it out until you get down to the bottom, until you get that squared. Anyways, there you go, graph it, figure out what the zeros are. Divide them out. And if you happen to get everything divided out, you find all 5 zeros, factor it. The graph first is something wrong here, specifically. Something wrong. Should say visual. You think should be different. It should say 3 zeros. I should show you 3 zeros. I'm not doing this. What are your zeros? Okay, start dividing them out. All the questions on Friday's test is all 10 points. It's the heaviest weighted question on the test, and it's kind of like this to some degree. You remember, you can reuse a line and get what is the remainder. 0. Something wrong. You're okay, for listening, but you guys are okay. This is your new plate. Not very useful. But it was your own. But you're on track to, you were probably going to figure out something to other. That's right, but in zeros. Start some difficult right now. Figure out the next 2 zeros. This is what we need to fix. 0. It should have written. It was not that bad. Because you only on zero. Now, since I got the zero, here's your numbers. What? I didn't say over. Then how it's back. Oh, you're the one who's working. Okay, so at this point in time, this was remembered. This would have been, yeah, really lucky. Then I could be like a ski on this 6 minutes. Worse for schools. You understand what you're mistaken that. But once you get your 4 eyes, I kind of need to finish this one. Y'all not as fast as my 5th grade class. Or first period. Let me do the 0 first because it's easy. 0 times 1 is 0. -2 plus 0 is -2. 0, 8, 0, -32. 0, -128. Now, had I not put that placeholder there, would this have been a factor? That's why the placeholder is important. You got lucky if your 0 wasn't the first guess. You did. Since I have a 0, I can reuse the other numbers. I know -2 is one of them. I'm sorry, you missed what the name is over 7. We need 4. That's how long synthetic vision takes, kids. Learn your multiplication tables. Now, the main thing is what I'm left with. I'm pretty sure if I gave y'all enough time, most of you would have gotten there. I don't have any disagreement with that. I think you would have gotten there. You are left with x squared plus what? 16. All right? I know Natalie and Maddie, a couple other people had it. You shift over. Now you're -16. What's the opposite of squaring? What is the square root of a -16? 4 what? 4i, plus or minus 4i. I have 5 zeros. It's x to the 5th. How many factors am I going to have? 5. Yeah, I'm going to have 5 of them. So I know that 0 was a 0. What's the factor? Just x. Remember, it's x minus 0. We talked about that. It's just x. I know -2 is 0. What's the factor? X plus 2. Signs are changing, huh? I know 4 is 0. What's the factor? X minus 4. I know -4i is 0. Plus 4i. I know that positive 4i is 0. It's minus 4i. I do think most of y'all would have got that, don't you? So you got a little homework on 3-6. Anything with a 3's due Friday. There won't be any homework tomorrow night. Other than twins and stuff. Well, your emphasis is on test prep. Thursday's a work day. Friday's test day. Friday is payday, kids. Called payday because it's when you get to see the profits of all your effort. Or lack thereof. One of the two.